இப்ப எவ்வளவு ஸ்டூடெண்ட்ஸ்க்கு சிஸ்டம் இருக்குமா?
Ma'am, 36 present, ma'am.
யாருக்கு இருக்கு இல்லை உங்களுக்கா? அங்க அங்க எவ்வளவு ஸ்ட்ரென்த்?
47.
அங்க இருக்கா எல்லாம்? ஒரு ப்ராப்ளம் இல்லையா?
இங்கதான் பார்க்கலாமா? இங்க ஒருத்தவங்க வர சொல்லுங்க.
இங்க வர சொல்லுங்க, நான் கிளாஸ் வெளியே எடுக்கிறேன். கொஞ்ச நேரம் வரட்டும்.
Talk about these two systems.
Ma, wear the mask. Ma, girls, wear the mask. சொல்லுமா. என்னப்பா என்ன சொல்லுங்க. என்ன சர்டிபிகேட் வந்துருச்சா? இல்ல, மேல செல்வராணி மேம் இருக்காங்க பாருங்க. ஆமா, டிபார்ட்மெண்ட்ல. We can start the class, ma. Okay. I have completed for you the instruction set. Have you gone to the microprocessor lab? A section? Yes. You have gone, right?
Yes, ma'am.
Okay, ma. So there they would have given the kit. Did you observe 8086 IC there in the board? Okay. If not, next class when you go, no, see in the kit. Okay. In the kit, it's like a motherboard. Okay. What you're using in your lab or system. In that, no, you'll be having 8086 processor IC will be there, and IC chip like this. Along with that, some more ICs will be there. Okay. Then you'll be having some keys like hexadecimal keys you'll be having, and a small display. Okay. 7 segment display, no. How many will be there? 1, 2, 3, 4, 5, 6. I think so. Okay, that will be there, right? So what today's topic is, we are going to learn about the 8086 pin configuration. Okay, internal architecture I have taught you already. We have 2 units: bus interface unit, execution unit. In each unit, what are the various registers are there, and what are the functions of various registers we have completed. Okay, and what is instruction set, and how to write small program using this instruction set which we have learned. Okay, now this is also one of the part B question. If they ask you to explain the pin configuration of 8086, okay, so you have to start. See, every processor, every IC, no, some IC will be 14 pin IC. Some IC will be 20, some will be 40. Okay, your 8086 is your 40 pin IC. So left side 20 pin, right side 20 pin. Okay. Then as usual, you know, it has got 16 data lines, 20 address lines. Okay. Third point, address lines and memory, no, which you're going to connect to your processor is linked. Okay. Because here you are having 20 address lines. So 2 power 20, 1 megabyte. So 1 megabyte of memory you can connect to your processor. That is the thing. Because you cannot connect more than that also. Because, for example, if you have 2-bit address line, 2-bit address line means 2 power 2. 2 power 2 means 4. 0, 0, 0, 1, 1, 0, 1, 1. So 4 location only you can address with the help of 2 bit. So 20 bit means that is the relationship between the address lines and the memory location. Okay, that you have to know. And one more thing, your 8086 will support multiplication and division instruction. So this is the main very, very important points that you have to know. Okay. Okay. See here the pin configuration of 8086. It's a 40 pin. In department, Selvarani ma'am will be there. Just no one is there. Who's there? Okay. Wait for some time. Okay. It's a 40 pin IC. Okay. The main thing. See, you are connecting your processor. These lines, where it will be connected. See, the processor will be connected to your input device. The processor will be connected to your output device. And the processor will be connected to your memory. Okay. So, these connection lines are called as your bus. Okay. Address bus, data bus and control bus together are called as your system bus. Okay. So, why we have to connect your processor to your memory? In order to read data, in order to store some data. Okay. So, what are the buses you have to connect? Address bus should be connected. Data bus should be connected. Okay. And you need some set of control bus also to control the operation. Okay. Suppose I want to read some content from the memory. So, first what you will do? You will send the address through where address bus to your memory. Second thing what you will do, you have to send suppose if you want to read data from the memory, you have to send a control signal. What control signal? Read control signal, RD bar. Okay, only then you are eligible to read some data from the memory. Third step, the data read will be sent through your data bus. Is it not? So these are the things you have to connect to your memory. So address bus should be connected, data bus should be connected, and read-write control signals should also be connected. Similarly, if you want to read some data from IO device, the same procedure. Address bus should be connected, data bus, because you have to know from which IO device you want to read data. After reading data, the data has to come from your IO device to your processor. So there should be a path, right? That is your data bus. Okay. So one more thing you have to know, always your data bus is bidirectional because data will flow from processor to memory, memory to processor, IO device. Whereas address bus is always unidirectional. See, while in the drawing I'll show you in the next class, you will have a arrow mark. A single head arrow mark means it is unidirectional. Both the directional, if you have an arrow mark, it is called as a bidirectional. Okay, today we will start. Okay, first I will complete left side. See this IC. Any IC, first you will fix it in the slot. After fixing, first thing, you have to give a supply, right? VCC is the power supply you have to give for a IC. How much power supply AC you will give or DC? You have to give a DC power supply 5 volt because digital. Next thing you have to ground. See the pin? Pin number 1 and pin number 20 VSS ground. 40 VCC connect to your supply first over. Next what you have to do, every processor will have a particular clock cycle, right? This 8086 will work in the clock frequency 5 versions are there, 5 megahertz or 8 megahertz or 10 megahertz. Nowadays if you see your i9 or i5 and all, it will work with the very high frequency in terms of gigahertz, terahertz. Okay, your 8086 first connect a supply VCC, then ground it and supply a clock. See the clock, which pin you have to supply a clock? 19. So your clock generator should be connected to the 19th pin. Okay, 19th pin. Okay, see this very carefully. Till now, it's a small things I have told. Okay. What's your supply? Which pin? You should not change the pin. Okay. One left hand side starting from 1 to 20, then 21 to 40. You should not change the positions. Okay. First one, we will cover the left hand side. First address, first we'll go with data bus. Next address bus. Next control bus. Okay. Address bus, how I have labeled this AD0 to AD15. A0, no? 0 to 15 means how many lines? 16 lines are there. Over. Okay. Why I'm giving A means address, D means data. So these lines, no, see the pin number. Pin number 16 to pin number 2. 2 to 16 if you see means. And pin number 39. Right? This pin, no, through this pin only, it is a 16 pin are there. Through this pin only, data will be transferred from processor to memory or memory to processor. So totally how many pins are there? 16 pins. Once again, ma. உங்களுக்கு வரல அப்போ போனதுல சாரி இன்ட்ரோடக்ஷன்ல வரல சரி நாங்க என்ன சொல்றோம் அப்படி சொல்றேன் கீழே ஆபீஸ்ல ஃப்ரண்ட்ல ஒரு மேடம் இருப்பாங்க ஆமா அந்த மேடம் okay. Through this pin, no, 16 pins are there. You concentrate on D alone. A, I will tell you. D0, AD, no, D0 to D15. So 16 pins are there. These lines only will be connected to the data bus. Through this lines only data will come to your processor and it will go. Okay. That is what is given here. See here? These, why I am calling as multiplexed means, through this lines, address will also flow as well as data will also flow. Okay. That is why it is called multiplex, but not at the same time. You can ask me, why should we have multiplexed? Why can't we have separate lines? Simple thing. If you have separate 16 lines, instead of 40 pin, you will be having how many pins? 56. And also you can see many pins are having two functions. The reason is that you cannot keep on increasing the pins, no? So your processor chip size will get increased, right? So a simple example is your road, right? Suppose, see now if you see means no, night time you are having heavy vehicle movement. Daytime what a college bus or public transports, right? Lightweight transports you can have. Okay. The reason is during night time the transportation is going to be less. Only movement.
Ma'am,
We can.
அஞ்சு பெங்களூர் போகலாம்.
இருக்குமா?
பெங்களூர்
Must see this. This is pin number 34. Okay. One more very important thing is every pin when you explain, no, you have to tell whether it is input pin number. You have to remember whether it's an input pin or output pin, whether it's active low or active high. What is the meaning? I'll tell you. See here, BHE is bus high enable. I have put bar. Bar indicates it is active low. That means, see the which pin number 34 is that signal. Okay, it's an output signal. That means what? From the processor, it is going outside. Okay, that is the meaning. That means this pin has got this functionality when the value is 0. Okay, when the signal value, because everything here 0 and 1 only. Right? Address bus, data bus means you can tell address 20, data 16. Whereas control signals and all, no, it is single only, 1 bit only, whether it will be 0 or it will be 1. That's it. Okay. So bus high enable, if you see means, okay, you can see here it is an active low. Bar means active low signal. It is an output signal. What this is going to indicate is, it's going to indicate that I told you address and data bus are multiplexed, right? So to intimate your processor that the data, the value in that AD0 to AD15 is data, or to indicate it is an address. For that, bus high enable signal is used. Okay. See this RD bar. RD means read. Bar means active low signal. I told you, when you want to read data from memory, send the address. Next control signal which you will be used. See, without control signal, no operation will take place in your without control signal, no operation can take place. Okay. Read means this will go to a memory. It will enable your memory and read operation will take place. Okay. So RD bar. Similarly, if I want to read from input device means I have to place the address of the what is that port address. Second thing, I have to send an RD signal. Suppose I want to write some data means you have a different control signal WR bar. Okay, so RD bar is an output signal which will go from your processor to your memory. Okay, memory, this RD bar will be connected to your memory RD bar. Directly it will go to the memory. Okay, when the memory see the value is equal to 0, it will understand, okay, processor is trying to read. Okay, see, as a human, you can talk, right? You can talk and instruct. Whereas a processor, memory, how they will communicate? They will communicate only through the control signals. Okay, so memory will see RD bar is equal to 0. So it will understand. Okay, processor wants to read the data. Okay, for that only it is used. Okay, this is very, very important. See, ready signal, pin number 22 ready. Okay, when this is input or output, it's an input signal. Okay, from where this input is coming? Okay, that is the thing. See, when you see your processor is connected to your input and output device. When you compare the speed of the processor and the input and output device, processor speed is high compared to your input and output device. Okay, when the processor is trying to read some data, since IO device is very slow, the processor has to wait. It's a waste of time. So what is the option is, the processor will initiate the read operation. After that, it will do some other work, some other computation. Okay. Okay. When the IO device or the IO device is ready to transfer the data, it will intimate your processor through the ready pin. Okay. Is it clear? Since processor and IO device are of different speed, okay, processor need not wait until the data is transferred. Okay, so here input device is intimating your processor, okay, now data is ready to be transferred. Okay, so when ready pin is equal to 1, okay, data will be transferred from input device or input device to your processor. Complete everything and come.
ரிப்போர்ட் கூட வேணாண்டாங்க. ஏ கார்டு வந்து ஆள் இல்லையா வந்து வாங்கி போனாங்க.
மிச்சம் எல்லாம் முடிச்சிட்டு வாங்க. எதுவுமே முடிக்கலையே. அலுமினியம் வந்து சரண்யா மேம், உங்க மென்டர் யாரு? சரி, ஓகே. சிஎம்சி வந்து 3rd பே. ஏ கார்டுலாம் சப்போர்ட் ஐடி கார்டுலாம் முடிச்சிட்டு வாங்க.
அதற்கு ஆள் இல்ல. அவங்க என்ன இங்க முடிச்சிடுவாங்க.
இல்ல. ஃபர்ஸ்ட் மென்டர் இல்லையா, சிஎம்சி முடிங்க, அலுமினி முடிங்க, ரிப்போர்ட் கார்டு வேண்டாம், ஹெச்ஓடி கடைசியில ஐடி கார்டு முடிங்க, இதெல்லாம் முடிக்கணும்.
சிஎம்சி பேத்ரியா
மணிகண்டன் சார் இருப்பாங்க. 3rd லேப் தெரியாத மாதிரி அடிச்சா அடி. என்ன பே3 தெரியாதா? 3rd லேப் பே3 தெரியாதா? என்ன சொல்றாங்க?
பிரின்சிபல்ட்ட கேட்டு சொல்றாங்க, சைன் பண்றாங்க. பிரின்சிபல்ட்ட சைன் வாங்கி கொடுத்தா குறை சார் இருக்காரு. முகமது போலீஸ்.
ஓகே சாரா? ஓகே சொல்றாரா?
வாங்கி சொல்றாங்க. ஆனா சைன் வாங்கிட்டு கொடுக்குறேன் அப்படின்னு.
நீங்க என்ன கம்பெனி மென்ஷனே பண்ணலையே?
கம்பெனி நேம்
மென்ஷன் பண்ணுங்க. இதுல எதுவுமே அட்டாச் பண்ணல. கண்டிப்பா எப்படி பிரின்சிபல் ப்ரொவைட் பண்ணுவாரு? ஆமா, கண்டிப்பா வேணும். பிரின்சிபல் இப்ப கேட்பாரு, அதுல அட்டாச்மெண்ட் இல்லாம எப்படி சைன் போட்டீங்கன்னு. ஆமா, கண்டிப்பா கேட்பாங்க. இந்த லெட்டர் மட்டும் பிரின்சிபல் சைன் போட மாட்டாரு.
சரி.
ஓகேங்களா, அதை முடிச்சுட்டு வாங்க. Ready is clear, right? Okay. See the reset. See, we have completed the left side. See everyone. We have completed left side. First pin and 20th pin is the ground. 19th pin is clock. 2 more pin are there. I'll tell you. Okay. 2 to 16 address and data bus. In the similar way, 40 pin is supply. 39 to 36 is what is that? 38 to 36 multiplex address and status signal. Next is bus high enable we have completed, and the 32 pin is a read signal. Okay, and ready signal we have completed, and now it's a reset. Reset means it's a resetting your processor. Okay, it's also an active high signal. What it will do, its operation is to whatever the activity is running on your processor, right? It will terminate all the activities. That is your reset. Okay. See, apart from this, see, this 2 pin is very, very important. Okay. Interrupt pin. There are 2 interrupt pins. One is INTR. Other one, 17th pin is NMI. It is called non-maskable. See, everyone are here, huh?
Yes, ma'am. Yes, ma'am.
Okay. There are 2 interrupts. In 2 mark also I will ask you, what are the 2 interrupt pins in 8086? One is INTR. Next is NMI. Next slide I will show. It is called non-maskable interrupt. INTR. See, what is this is, see, what is interrupt and how the interrupts are handled is important. Okay. Processor can do only computation work. Okay. Processor will do only computation work. Other works, reading, writing and all, it will become a burden for processor. Is it not? So what will happen is, you have connected the input and output device. Okay. When the data is ready, when the data is not ready, your processor cannot keep on going and checking, right? So what the processor will do is, it will do its operation. When the data is ready, your IO device will come and interrupt your processor. Interrupt means what? It will intimate. Through which in the pin it will intimate is INTR and your NMI. Okay. You can ask me, we are having only 2 pins, so only 2 devices we can connect. It is not like that. In INTR pin, we can connect one controller called as interrupt controller. One interrupt controller can handle 8 devices. Like this, we can connect an interrupt in cascade. So we can handle many IO devices. Okay, one thing. Second thing, there are 2 pins I told. One is INTR, other one is NMI. Okay, so here itself we have to give the priority. NMI has got the highest priority compared to INTR. Meaning, see, in the class, if 2 students are asking the question at the same time, I have to answer, right? To whom I will answer? That is the thing, right? So what I can do is, I can set the priority. Okay, A has got the highest priority, B has got the next priority, B has got the next priority. என்ன வேணும்? இல்லன்னா என்ன? இல்லன்னா வெயிட் பண்ணோம். பின்னிடுவேன். இங்க வாங்க. எதுவுமே முடிக்கல, போய் ஏ கார்டு ஐடி கார்டு முடிங்க. சரிங்களா? இது அப்புறம் வரலாம். ஃபர்ஸ்ட் இது ரெண்டும் மெயின் முடிச்சிடுவாங்க. அக்கவுண்ட்ஸே கிளியர் பண்ணல. அக்கவுண்ட்ஸ் கிளியர் பண்ணுங்க. ஏ கார்டு முடிங்க, ஐடி கார்டு, டி கார்டு எல்லாமே முடிச்சுட்டு கடைசியில வாங்க. Okay. Here. Okay, so what I do is, student A has got the highest priority, student B has got the next priority. Okay, when both are requesting at the same time means, I will see who has got the highest priority. Those students' request will be taken first. Next, after that, the next student will be serviced, right? The same way here also, I'll be connecting the devices in interrupt pin, NMI pin. I will also connect some devices in INTR. Okay. When both the pins, the value is 1, that means what? They are interrupting. So what the processor will see, which has got the highest priority. Okay, NMI has got the highest priority. So the request in that pin will be serviced first. Then after completing only, it will take the request of the next pin. Okay. So this is very, very important. Okay. I will 2 more question. What are the 2 interrupts means? NMI, INTR, maskable. Why I call non-maskable means you cannot hide their request. Definitely you have to service that request. Whereas INTR is not like this. Okay, you can mask it also. You can service it, or without servicing also you can leave it. Okay. That is what is this NMI, non-maskable interrupt signal. It is an active high signal. Okay. So that's it. This left side, all the signals I have taught you. Okay. Next class, a few signals are left over. That I will teach you next class. What signal, main signal is? See the pin number 24 to 31. Okay. This has got dual functions, right? So this is very, very special thing. What is what I will tell you? One minute. So INTR, what I told, same thing only. Test I will tell you. Wait. Clock I have told. VCC and supply also I have given. This is one important pin. I will teach you. Then I'll wind up. See the pin number 33. Okay. MN is very important pin. 2 mark I will ask you. MN/MX. MN means minimum, MX means maximum. What do you mean? Okay. If a system means you'll have your processor, input device, and you'll have an output device. Okay. In your lab also, if you see means you'll have one processor. So, example I'm telling, it is a minimum mode operation. Suppose in your system, if you have more than one 8086, or if you have one 8086 and one co-processor 8087. So if you're going to have more than one processor in your system, it is called maximum mode. Okay. So MN is an active high, MX is active low. MN/MX bar is equal to 1 means you're operating in minimum mode, only one processor. Suppose MN/MX bar is equal to 0 means 0 when will happen? MX bar. 0 means it is a maximum mode. So your system is having more than one processor. Is it clear, everyone? So this only is very important. Minimum/MN/MX. So depending on that only, tomorrow I'll teach you. Okay. These pins have got the functions. Here, 24 pin to 31 will have 2 functions. Whether you're going to operate in minimum mode or you're going to operate in the maximum mode. Okay. Is it clear, everyone?
Yes, ma'am.
Okay. See, next time when you go to the lab, you just see the kit. Just please don't type. See in the kit what are the ICs are there. Where is your processor 8086? Okay, what are the other IC? What are the IC numbers? It will be on the top of the IC. Okay. Apart from that, where is the display? What are the other things are there? You just see that and come. Because in 3rd unit only, you will study other ICs. 8255, 8251, 8279, 8253, 8258, like this, 6, 7 IC. First, you will study pin configuration. Next, internal block diagram. And what is its functionality. Okay, that is it, 3rd unit. Is it clear, everyone?
Yes, ma'am.
Okay, ma. We can wind up. Okay. Tomorrow class we'll see. Thank you, students.
Thank you.
Thank you, ma'am.